All right, welcome. This is the lab lecture video for torque. For those of you that missed the torque lab due to hurricane number 26 or whatever it was. Okay, so we're going to be talking about torque. When we think about torque, and you can follow along in your lab manual as we go over this, torque is a force and a distance, right? But it's not the same as work. We saw this with work. It even has the same units as work, newtons times meters, or as we'll sort of look at later, we'll look at the units kilogram, meter squared per second squared. But it's different here. Instead of work, where we're trying to move something a certain distance, this distance is what we call, the lever arm. So the lever arm is where the force is acting with respect to how the thing rotates, because torque is all about rotation. So we need to know specifically where is the rotation point, where is the axis. This is sometimes called the balance point or the pivot point. And R, the lever arm, is the difference between where the axis is and where the force is. So it's the position of the force. And this is going to be obvious in our example today. Whoops, sorry. My drawing with my finger there. Because our example today is going to be a meter stick. This is what you're going to set up in lab. We'll get back to the references, but imagine a meter stick where 0 centimeters is that end and 100 centimeters at the other end. And we're going to start out by balancing it or putting its axis at its center of gravity, which is going to be basically right in the middle here. So this is going to be the axis. It's going to be close to 50 centimeters, might be a little bit different for each of our meter sticks. But the idea is here, if you apply a force off axis to one side or another, we're going to do it by hanging a mass. So you're going to apply a mass, call this mass 1 here. What's going to happen? This thing is going to rotate, right? And that's what torque is, that you are applying a force, right? In this case, our force is this mass 1 times gravity at this particular point. And we'll just say that this point is happening at about 10 centimeters. And the lever arm is the distance between the axis and where you are applying the force, right? So in this particular case, we have our lever arm R is equal to an axis at 50 centimeters minus the position of force at 10 centimeters. So we have a lever arm that's 40 centimeters long. Okay, that's exactly what you're going to be doing in lab today. While we're looking at this, there's some other things that we need to know about torque. And one is, by convention, we have what we call positive torques and negative torques. So if I hang a mass on this side, it's going to cause this thing to rotate this way. It's going to cause a torque in the clockwise direction, right? It's going to rotate clockwise. By convention, we call that a positive torque. Remember our torque formula up here, right? Torque, force, lever arm. Our lever arm is a positive number. Our force is also going to be positive. I know we got that gravity in there, but we're taking care of direction by this convention. Torque's positive in the clockwise direction. Now imagine that we hung a mass on the other side. Okay, this is mass 2. It's also going to have a force, but it's going to cause a rotation in the opposite direction, counterclockwise. We call that a negative torque, right? So by convention, and I just totally got my clockwise and counterclockwise backwards. Y'all, rewind just a second. I'm not going to stop it, but rewind. Clocks go this way, right? So this is clockwise. Clockwise is negative, and this is counterclockwise. This way is counterclockwise is positive, okay? Sorry about that. Um, we'll get back on track this morning. Okay, so that's kind of basics of torque, but we're going to be looking at something else today, and that's this idea of equilibrium. So when we think about equilibrium in terms of torques, we're thinking about not rotating, right? If torque causes this rotation, equilibrium is where you don't have any rotational velocity. And you get that when the torques are balanced. A way to think about the torques are balanced is you can say that the sum of the torques is zero. Remember, we're dealing with forces. They have magnitude and direction. So when we're thinking about direction, we say, oh, okay, so that means the positive torques have to have the same magnitude as the negative torques, right? If they were both absolute value, but we put in the direction there with a negative sign, right? So the positive torques equal the negative torques, or their magnitudes are the same if you're taking the direction out of the equation. Okay, so this is the state we are going to be dealing with. That means your meter stick will not be rotating. And it also means that you have a balance not of mass, but a balance of mass times lever arm. So let's go back and think about what our torque equation was. So and see what I'm talking about here. It was force times the lever arm, right? Well, both of our forces in this case are going to be gravity. And when I say both of our forces, I mean the one causing the positive torque and the one causing the negative torque, right? They're both going to be due to gravity because we're hanging masses on different sides. So we're going to simplify things a little bit. So normally when you have this equation, positive torques equal negative torques, you would have the force, mass 1, times gravity, times the first lever arm is equal to the negative of mass 2 times gravity, the force in the opposite direction, times the second lever arm. And you would have to put everything in those units. Remember, we said kilogram, meter squared per second squared. So all your lever arms would have to be in meters and all of that. We're going to simplify things. This is just for today. This is to make things easier on us. We are going to notice that we have gravity on both sides of the equation. And we are going to measure measure the lever arm in centimeters and our mass in grams. So your torque equation is going to look like this. M1R1 equals negative M2R2, and the units are going to be grams centimeters. Okay, this works really well for our setup. It keeps you from having to convert everything and multiply everything by 9.8 or 10 or whatever. So this is our balance, our equilibrium torque equation that you're going to be using today. That's equation 4 in your lab manual. Okay, one more piece of physics, and then I'll talk about the individual procedure parts that you have to do. The last piece of physics that I want to talk about is center of gravity. So center of gravity, you're probably familiar with this term. It's sort of the place where we consider all the weight of the object to be, right? So the weight of the object is at this point. And in terms of torques, we need to think about how that weight of the object is going to act. So here's the picture. Here's our meter stick. right? 0 centimeters here, 100 centimeters here. Let's say that the center of gravity is here in the middle, 50 centimeters. Should be close to that. Not all our meter sticks are perfect. Might be 49 or 51 or whatever. So that's our center of gravity. In the previous example, and for the first part of this, you're going to be putting your axis there at the center of gravity. But what happens, imagine that we change that, right? That we put our axis someplace else. What if I put it over here? Right now my axis is here. I'm not hanging any weights off of this yet, but will this object, will this meter stick undergo torque? Right? Will it be in equilibrium where it's not moving, or will it move? Imagine it in your head. I think you could imagine that this thing will flop down this way. It'll experience a torque. Why is that? Because we consider the weight of the object to be at the center of gravity. So gravity, force, is acting right here. It's the weight, in this case, of the stick, of the meter stick, and it's going to produce a torque. Okay, in this case, a negative torque, the way I've drawn it. So you're going to be setting that up as well, thinking about where the center of gravity is and the fact that the center of gravity is the place where the torque happens if you are off axis with your balance point. Okay, so I'm going to stop that video and then I'm going to make another short video just talking about the procedure. Okay, I'll see you all then.